The other thing I want to do though is that that's not the only, that was like A or whatever, right? That's not the only particular solution you were given. Was there another one?
There was.
What was it?
Y brackets 2 is 0.
So y brackets 2 is equal to 0 was part B, I suppose, yeah? Okay. And now when you try do this, Harry, can you remind me again, which one's x, which one's y in this one? Like what do I? Yeah, so when x is equal to 2, y is equal to 0, you don't have to keep rewriting this every time, but you do have to write it out if you're not sure about which one's which, right? But when you put this in, notice what happens. So if I go back to my general solution, if I put y is equal to 0 and x is equal to 2, what do you notice when I try and solve for k here? Well, how would I solve for k? If I try and do what I did over here, multiply both sides by the denominator, right, you get, well, if I multiply with this whole denominator, I get 0 on the left-hand side. And then I get like, yeah, okay, so we just broke mathematics, right? And so that's the answer, right? No, so what you have to be aware of is in mathematics, sometimes when I give you a procedure, like there's sort of caveats along with that. Right? Think back to actually a really good example is, I'm not sure you remember this, in advanced there's situations where you use logs to solve for unknown powers. But if you try and put the log of a negative number in your calculator, do you remember what happens when you do that?
I'm assuming math error.
Yeah, it's a math error, right? Because if you think about the logarithmic graph, it doesn't work, right? So what you have to be aware of is, thanks Liam, just leave it there, thanks. What you have to be aware of is sometimes like the tools we give you in mathematics, they don't actually work for certain situations. And this is an example of that. Like they're giving you this information and you need to find the answer to it. But like the method I've told you doesn't really work, okay? So that's the first thing to be aware of. If they've given it to you, like the likelihood is that the question's right? So you can kind of assume that. So we want to think about, okay, there's obviously a solution here. How do we kind of find it, right? What I want to do is, this is where the visual representation is very powerful. Let me bring this up for you. Have a think about what options we might have, because obviously this approach is not going to work, right? So this is what the visual representation looks like. So this is the slope field generator I was telling you about, right? You can actually put in, I think I prepared this one earlier, it's the same function, right? And so you can actually type it in and it will change. Like if I get rid of one of the variables, it changes the slope fields. Pretty cool. But for some reason, like it's...
Wait, but that's wrong. That's not what we're doing.
Oh.
X the square should be...
Ah, cool. All right, so just checking if you're all still awake.
I mean, I wasn't this morning.
Y squared. Thank you, James.
Ah, got it again.
So, and you notice like sometimes it's a bit patchy. Like for some reason it's just lost the stuff there. I don't know why. So let's have a look at this. This is our differential equation. This is the slope field. Okay, so remember, there's a connection between what's happening algebraically and what's happening visually. Like when you graph this, what do you expect to happen when I type it in? Y is equal to 2. So what do you notice? Kind of, I don't know if it's super clear, like here. Again, like this is why it's not as clear on this one because the lines are so big, right? But what's meant to be happening is that these are meant to be representative of the gradients that are there. Like if you have a look, it's typically following the slope of the lines that are there. It doesn't actually pass through any of the points, which is why it's like not as clear. But it does pass through the point 1/2 if you look over, where is it, like roughly there? If I can get my finger, kind of. No. Oh, I just got it there. So 1/2, there you can see it there, right? But what else do you notice is in this slope field, what's this purple stuff on the x-axis? Can you guys see that? Yeah, right. So it looks like, if I can try and zoom in a bit, it looks like that if I have a point that goes through, what point was this? 2, 0. So if you go to 2, 0 here, right, you can see how it's a horizontal line. Okay. So when I think about a solution that fits that, if I tried to trace along the isoclines, what would I get? A straight line. What's the equation of this particular straight line here? Y equals to 0. So let me draw that out for you. Y is equal to 0, right? And you can see it does satisfy it, right? So can you see how visually y equals to 0 is the solution to this differential equation? Does that make sense? So I'll say it again, right? The idea is that this is the solution to this differential equation, because we wanted an equation where it satisfies this particular differential equation, and we can see this visually, and it has to go through the point 2, 0, which we can see that this does. So the question is, how would we actually know that without, because we obviously can't graph this in an exam, right? The key lies on this. If you go back to the differential equation, if you have a look at it, and if a differential equation, if it has any roots in this equation, so if there's anything that makes this equal to 0, then for the y value, it's very important because there's two variables here. We're only looking at the y value here. Yeah. If there's any y value that's a root for this equation, then that's actually a constant solution to the differential equation. So that's something you need to make a note of. So for constant solutions, where should I write this? I'll write it like over here, I guess. So constant solutions, always check for constant solutions for a differential equation. And so once you know that, it'll become a lot more obvious now, because you'll see certain situations where y is actually the solution for y, a value for y can be a root for this equation. Like in the next one, there is one. But obviously, if you have a case like this, like y, there's no root for this one, but there's no value for y that's going to make that whole thing equal to 0. And if you want to think about why this actually works, is because the reason why it has to be the y value is because that's kind of what creates your horizontal line. Yeah? If x is equal to 0, you're going to get all the points along here being a horizontal gradient, okay? But because it's the y value, it's going to create an actual line in this case, yeah, not some disconnected bits, okay? So that's where this kind of question works, and that's how you can check for constant solutions.